All right, we're Trig lecture 11:30 and 12:1. The student will use the law of sines to find missing angles given an ambiguous case. Now, the word ambiguous means that something can be interpreted in more than one way. In our case, we're going to have a possibility of two ways that it could be interpreted. And I'm going to discuss that with you, the ambiguous case and the law of sines. What we're going to run into today, there's more than one situation going on here, but what we're going to be doing is talking about one case of the ambiguous case. Remember back in geometry when we were using side angle side and angle side angle and angle angle side to prove that two triangles were congruent to each other? This is way back when, but this was the notation that we used. And what we're going to be talking about with the ambiguous case is when we're going to be given an angle, a side that is adjacent to that angle. So I have an angle and a side, and then I'm going to be given the length of a side that is opposite that angle. So I'm going to be given, let me draw that again. Draw it a little nicer. There, that's a little bit better. Not much better, but okay. So what I'm going to be doing is I'm going to be given an angle, a side, and another side. And for obvious reasons, I'm not going to denote it using those letters. If you'll think about it, I'm not going to write that up here. But it's going to be an angle, a side, and then the opposite side from the angle given. Say if this is angle C, it'll tell you side C is, and it'll tell you how long it is. Let's say that this would be 14. I'll just make that up. If this is 14, if it's a side and then an opposite side here, angle side side, which is what we're going to be doing every time today. If this side is shorter than this side, there are two possible triangles that could be formed here. It could be this triangle, or if you think of this as a pendulum and it just swings over here like this, it could be this triangle. See if I can draw this neatly. Yeah. If these are both 14, with knowing that the side opposite this angle is 14, I could draw the triangle this way, or I could draw the triangle this way. And that's why it's called ambiguous. It could be either one of those. So what we're going to do is find both possible values. So we're going to answer our question. We're going to be asked to find the measure of angle B in this case. We're going to be asked to find this angle right here. And since it's two possible angles, I could find it using this case, and then I'll consider the other case, and I'll find this angle right here. Now here's the neat thing. When I find one of them, I'm going to automatically know the other one. Okay? So if I find this angle right here, we'll call it angle C, just for grins. Then I'll automatically know this other C, I'll call it C sub 1, just to call it something else. It's not the same value as this. But these two are always going to be supplementary. They're going to add up to 180 degrees. So if I find out that this is 50 degrees, for instance, then I'll know that this one has to be 130. Okay? So what we're going to do is we're going to be given a situation. Every single one of our situations is going to be like this. You're going to be given an angle, a side, and another side that is opposite the angle that you're given. I would advise you to set it up just like I've done. We don't know how long this side is. They're not going to tell us how long this side is. So represent it as a dotted line, draw the side that they give you, the angle that they give you, and the other side will be shorter than this. It'll be long enough to reach the other side, which is a possibility. It may not be long enough, in which case you won't have a triangle if it's not long enough to reach this side. But we'll talk about that later. We're just talking about one specific case of the ambiguous case. And in this case, we'll have the other side that's given to us. That's a horrible. But let's say it's 14, for instance. It could be here, or it could be drawn here. And we want to find these two angles. And I'm going to show you how to do that. Okay? Hopefully I'll show you in a way that makes sense. So let's run through this again. We'll run through the exact same idea that I hope I described right there. Find the measure of the indicated angle. We want to round our answer to the nearest tenth. We're given the measure of angle C. We're given the length of side B, which I'm going to draw the way I've shown you to set it up. It's going to be the one that takes off at an angle like this. And side C is opposite angle C. So I'm going to draw what I'm given just like this. Okay? Here we go. I'm given, I'm going to work in blue. I'm given, measure of angle C is 39 degrees. So I'm going to say, well, there's 39 degrees, roughly. Okay. Measure of angle C is 39 degrees. I'm given the side adjacent to it, so I'm going to call this B, side B is 30 kilometers. And I'm given side C, the opposite of this angle, this is angle C, that's what they told us, is 26. So it could be drawn like this, or it could be drawn like this. Whoops. Think of it as a pendulum. That's a really horrible pendulum drawing. Think of it swinging like this. Could be two. So my technique to solve this thing is to find this, oh doggone it, that was not what I wanted to do. To find this angle first. I'm going to be dealing with this triangle first. Oh, it's not cooperating with me. I'm going to find this triangle first. I'll find this angle, which is what I'm asking. I'm going to call it angle B. Here's side B. Since side B is 30, there's angle B, angle C. I'm going to find some angle B using the law of sines. And then I'm going to find this angle B, the other possibility. I'll call it B sub 1. And these two will be supplementary. So if this turns out to be, again, 50 degrees, this would have to be 130. We're going to be rounding to the nearest tenth. So we'll deal with this one here in just a second. Here we go. I've got a triangle drawn, 39 degrees, 30, 26, I've got to put that up there, 26 kilometers. I want to find the measure of angle B. And there are two possibilities because this side is longer than this side. The opposite side is shorter, so it could pivot around and form two different triangles. So we're going to find this one first. Here we go, using the law of sines. 26 is to the sine of 39, so I'll do the as, whoops, we'll move this out of the way. 30 is to the sine of B. That is 30, isn't it? Yes. Okay. Now I'm going to cross multiply. 26 sine B is equal to 30 sine 39. I'm going to divide both sides by 26. I'm trying to isolate B. I just divided both sides by 26. So when I divided this side by 26, I was left with sine B. I divided this side by 26, I'm left with this. And now I don't want sine B, I want B. So I'm going to take the inverse sine of both sides. Of this mess right here. Okay, and that will give me this angle. And once I know this one, I automatically know this one. Once I find this angle, I'll automatically know this angle, because these two angles will always be supplementary. I hope I said supplementary last time. They will add up to 180 degrees. Hopefully I didn't say complementary. If I said complementary last time, I meant to say supplementary. So here we go. Using my handy dandy calculator. Angle B is inverse sine of that mess. 46.6 rounded to the nearest tenth. So I'm going to say angle B. Whoops. Might as well stick with blue. The measure of angle B is either 46.6 having solved this triangle, and always solve this one first, that way you'll get the acute angle first, and then from that information I can say, or it could be the supplement of this angle. So I subtract that from 180. It could be 133.5. Because we have an ambiguous case, we were given angle side side. And we saw that the adjacent side was longer than the opposite side, which means that this could form more than one triangle. It could be drawn like this and form this triangle, or it could be drawn like this and form this triangle right here. And we just found both the angles. We found the acute angle first, the smaller of the two. And as soon as we found this one using the law of sines, we automatically knew the other possibility. Because we were dealing with an ambiguous case, it was interpreted in more than one way, and hopefully we found the right two answers. I've got the answer sheet here. Let me see if I did it right. Yay! Well, that should be 0.4 though. I rounded it incorrectly. So there we go. I'll do another one. Once you've done a couple of them, they're pretty straightforward. Just got to get used to the idea you're given angle side side, how to set it up. I'm just showing you how I personally do it, and it works for me. So I'm given angle B is 15 degrees, angle A is, or side A is 26 meters. That would be adjacent to angle B. It's not opposite angle B, because if it's opposite angle B, it has the same letter, C, angle C, C. So it's an adjacent side. And then I'm given another side that's not opposite. So I'm given angle side side. And I'm asked to find the measure of angle A, which is opposite this one. So I say, hey, that's angle side side. I'm going to have an ambiguous case. So I'm going to set it up like this. Scoops that up just a little bit higher. There we go. I want you to be able to see it also. So I'm going to go, well, I don't know how long this side is because they didn't tell me. It's an ambiguous case because they gave me angle side side. Angle B, I'm going to call this angle B 15 degrees. It's the only angle they're giving me. There we go, 15 degrees. They're telling me that angle side A is 26. Well, they're giving me side B, which is opposite. So this has got to be A. And they gave me meters, 26 meters. Draw that. Don't really need that, but I'll put it in there anyway. Then they tell me that B is 17, and I see that this is the opposite side from angle B. Opposite side, B. It's smaller than the adjacent side, it's shorter, so there's a potential that it could look like this, or it could be drawn like that. Think of it as a pendulum that just swings. It could form two triangles. That's the ambiguity involved. So I'm going to solve this one first, find this angle, excuse me, and then I'll automatically know this angle because there'll be supplements. Here we go. Solving. I think I'll scooch this out of the way. 15, 26, 17. A is 26, that makes this A right here. And I'm looking for the measure of angle A. So I'm going to say, looking at this triangle using the law of sines, 17 is to the sine of 15 degrees. Excuse me. As 26 is to the sine of A, law of sines. Cross multiplying yields 17 sine A is equal to 26 sine 15 degrees. Solving for sine A, I'm going to divide both sides by 17. This mess. It's supposed to be degree symbol over 17. And I don't want the sine of A, I'm looking for the measure of angle A. So if I know that the sine of A is equal to this, then the measure of angle A is the inverse sine. So I'm going to take the inverse sine of both sides and get A by itself. On this side it just turns into an A. On this side I've got the inverse sine of this chunk right here. 26 sine 15 degrees over 17. And I'll round that to the nearest tenth using my handy dandy pocket brain. Here we go. 26 sine 15. I'll take the inverse sine of that. 23.3 is what I get. Now as soon as I know that, this is providing I haven't made any mistakes. Let me check. Yay, that's one of the answers. As soon as I know that this is 23.3, then I know this other one, the other possibility, if this is 17, I just found this is 23.3. It doesn't look like it because my drawing isn't to scale. I know that this is the supplement of that. This, if I looked at this triangle right here, the other possible triangle that I could draw, this would be the supplement of the one I just found. So we always look for the acute angle first, because our calculator will give us that automatically. And then we subtract that from 180, and that gives us the other possible angle. So 156.7, roughly. Forget what I just said. And then I state my answer. I'm looking for the measure of angle A, so the measure of angle A could be approximately 23.3 degrees or 156.7 degrees, because we're dealing with an ambiguous case. And it's easy to remember the ambiguous case because it's angle side side. It's not one of these. And I can't spell angle side side on the board, so it's easy to remember. And hopefully that's right. Let me see if that's what this. Yay! So there we go. So we're given an angle, a side, and a side that's opposite the angle. If they give us angle C, this will be side C, and some other angle. And we'll always be looking for this angle down here. Just today, it's not the only ambiguity that's involved, but for today, this is where we're starting with the ambiguous case. Two possibilities. Oops, I'm making a mess. Law of sines, the ambiguous case, you can do this.